Good morning. Today we'll be discussing about the last topic of our third module, which is doubly linked list. So as the name says, this particular link or this particular linked list is having double links per node, and hence the name doubly linked list, which means when you draw the structure of a node in a doubly linked list, it will have at least one data field and two link fields. One will be connecting to the next node of the list and the other one will be connecting it to the previous node of the list. So all the nodes in a doubly linked list are linked together by multiple links, or to be precise, two links. Okay, and this will help in accessing both the successor and the predecessor node, or both the next and previous nodes for any arbitrary node within the list. Okay, whether you take the first node, whether you take the second node or the last node, every node will be having a connection to its previous node and its next node. So as I said, there will be three fields at least, one data field and two link fields. The L pointer or the left pointer, which is connecting to the previous node, and the R pointer or the right pointer is connecting to the next node. Okay, then the last node will be having a next value null. Similarly, the first node will be having a previous value null. Then as usual, the start will be marked using a header pointer, or you can even have a specific dedicated header node. So this is a pictorial representation of a doubly linked list. As you can see, this is the header. Then this is the null pointer, which indicates the previous node of the previous node link value of the first node. So as usual, it should be null. Then similarly, this is the next pointer value. This is the next pointer field of the last node, that is also set to null. All the other links will be having the address of the corresponding previous or next nodes. So this is a sample of a doubly linked list. Let's see how to program a doubly linked list. So we'll be talking about various operations. So the various operations that you can do is, any operations that is performed inside a singly linked list can be performed inside a doubly linked list as well. One good thing is that you don't have to have only the forward traversal. You can even have the backward traversal also. So that is the advantage of having doubly linked list. You can have forward traversal as well as backward traversal. So you can insert, you can delete, you can merge, you can copy, then you can traverse through the linked list. So let's see how to perform insertion. So just like in the case of singly linked list, here also you have three cases to follow. First is, you're going to insert at the beginning of the list, then you are going to insert at the end of the list, and you're going to insert at any position which is chosen by the user. So in this case, first let's start with insertion at the beginning. So what we know, we already have that there is a linked list, there is a pointer called head which is pointing to the start or the first node of the linked list. Then you're going to create a new node. That new node is going to have its next field value pointing to the original first node of the linked list, and the header should now point to the newly created node. This is what the process is all about. So let's see how this can be done. So in the first case, what you have to do, you have to create a node, you have to get the data from the user, create a node, add the data to the corresponding data field of our newly created node, set the previous value as null, because this is going to be the first node of the list. So obviously it will be having its previous link field null. Okay, so what should be the next field? Suppose this was the first node of the list. If this was the first node of the list, obviously your head pointer, it is written as start here, the head pointer will be null. Okay, if the head pointer is null, then this is the newly created node and this is the only node of the list. So obviously the next field value of new will also be null. If that is not the case, which means there are already at least one or two nodes available in the list and you're going to add this node as the first node. In that case, what you have to do, you have to take what is the next field. So already we have head pointer pointing to the original first node of the list. So the address of the first node is right now available with the header pointer. So what you do, you set the next field value of the header pointer of the newly created node to point to the address that is stored within the header, which means the next field value of the newly created node will be having the address of the original first node of the list. Okay, and what you have to do, you are currently having the header pointer pointing to the original first node. You have to change the previous value. The previous value was originally null. You have to change it and you have to ask that value to be stored as the address of the newly created node. So this is how this is going to work. So now you have created the node, you have set the previous and next field values of the node as well as the previous field value of the original first node. Now the original first node has become the second node. Your node has been added to the linked list and this is going to be your first node of the modified list. So if that is the first node, the start pointer or the head pointer should point to this newly created node, and that is done in step 7. So this is all about insertion at the beginning of a doubly linked list. So what you can do is that you can take an example, you can have a sample linked list, a sample doubly linked list, and then you can try inserting a node inside in the front, in the end, and in any position. You can take a sample, you can perform it and find out how this works so that you will have a better understanding. Second one is insertion at any position. Insertion at any position. So insertion at any position means the position has to be given by the user. So in this algorithm, there are two common approaches that you can actually use while programming for insertion at any position. Either you can take comparison with the data of a particular node and insert the new node after that node. That is one method. Or the user is saying that I need my newly created node to be the nth position node of the linked list, which means he is along with the data he is going to say the position where you actually want to insert this particular node. Okay, so he is giving you the position and he is giving you the data. So that is the strategy which is adopted here. Okay, so instead of PTR we have used temp here. So that's just a temporary pointer. So what happens is that initially temporary pointer is set to point to the header, which is the starting position of the linked list, and you have a variable called I that is going to count for the position. Okay, so initially it is set to 0. So now you're going to have a loop where you're going to compare whether I is less than 0 and temp is not equal to null. So the two cases are you haven't reached your user specified location yet and you haven't gone out of the doubly linked list. So that is checked inside the loop, which is written in step number 4. Okay, so what is the strategy that has to be adopted? In that case, you have to advance the PTR or advance the temp variable to the next node. So that happens, and also I is incremented. So initially it was 0, then it becomes 1, then it becomes 2 until you reach the specified position which is stored by the user. Okay. So in the step number 6, you came out of the loop of step number 4 because you have reached the position which was intended by the user. Okay. So if you have reached the position that was intended by the user, obviously you can create a node there. Okay. So what happens is that you are going to set up a temporary variable temp1, just like we are having ptr1, and that will be pointing to the node immediately after the current position of PTR. So if PTR is in 5, PTR1 will be in 6. So if temp is in 5, temp1 is in 6. Now as usual, you have to create a node, name it as new, then insert the data value that was collected from the user, that is inserted to the data field. Now we have got a previous field and a next field. Listen, this is going to be the 6th node of the list. Okay, this is going to be the 6th node of the list. So initially the original list was having that the 5th node is having its next field storing the address of the 6th node, and the 6th node is having its previous field address stored as the address of the 5th node. Okay, so this was the initial link between these two nodes. Now what you have to do, you have to break this. Okay, so if you're going to break this, you have to make it such a way that the 5th node is now going to point to the newly created node through its next field. The newly created node will be having its next field value pointing to the 6th node, the original 6th node. The 6th node will be having its previous field value pointing to the newly created node, and the newly created node will be having its previous field pointing to the original 5th node of the list. So this is the operation that has to be done. Now that is written in step number 6, C to G. Okay, so let's see. Now you have created a node, you have inserted the data field, you are now going to set the next and previous field value. So the 5th node is pointed by temp, the 6th node is pointed by temp1. Okay, so what you're going to do, you're going to set the next field value. Okay, yeah, I have replaced that temp1. The temp next, which was initially written there, I have replaced it with temp1 for your better understanding. So what you're going to do, you have set the data field, you're going to set the next and previous link fields. Okay, so the next field is going to point to the address which is pointed by temp1, and the previous field is going to store the address that is pointed by temp. Okay, so the new node is all set to join the family. Now what is to be done? You have to change the links of temp1 and temp2, the previous link of temp1 and the next link of temp. Okay, so the previous field of temp1 is now pointing to new. Similarly, the next field of temp is going to point to new. So what happened is that you came till the position which was indicated by the user, and after that you're going to break the link between that node and its immediately next node, and you're going to make this newly created node be inserted at that position. So that is how this is being done. Okay, so this is all about insertion at any specific location. Now when you're going to insert at the end, let's see how that happens. Okay, so when you're going to insert at the end, first what you have to do, you have to find the end of the original list, right? Then you have to create a node and merge this node to the end of the original list. That is what the process is all about. So what you have to do, first you have to fetch the data from the user. Okay, then you're going to create a node. Somehow you're going to insert it, so you're going to create a node. Then you create the node, you insert the data into it. Obviously this is going to be the last node, so the next field of this newly created node will definitely be null. So that is also set. Okay, now you have to know whether this particular node was the only node of the list. Okay, so if this was the only node of the list, then obviously header will be having a value null. So if header is having a value null, you're going to make the header point to this newly created node, and you're going to set the previous link field of the newly created node to have the value null. So that is all about. Then you can exit. Else, that means there is at least one node already available inside the list. Okay, and now you're going to make your newly created node the last node of the list. So first you have to travel through this doubly linked list till the original end of the list. Okay, so you are having temp, or what you want, if you want you can take PTR. Okay, so PTR is going to travel till the end of your doubly linked list. Okay, so how will you know you have reached there? You are checking whether the next field value of PTR or temp is equal to null. Okay, if it is not equal to null, you are advancing PTR. So at one point you can see PTR next is equal to null, which means PTR is currently pointing to the last node of the list. Okay, now you have to set your newly created node. So newly created node is available, PTR is available in the last node of the original list. What you have to do, you have to set the previous link field of your newly created node to point to the node that is being pointed by PTR or temp. Similarly, the next field value of PTR was actually null. You have to replace it with the address of the newly created node. So that is done in step number 7, C and D. Okay, so that's it. You are done. Your newly created node has become the last node of the list. Your process is done. So this is all about insertion. Okay, you have discussed three methods, three ways, which is insertion at the beginning, at any position, similarly insertion at the end. Okay, next is about forward traversal. Just like we have it in the syncly linked list, you can use the next field values. You have to start from the beginning. You have to travel till you become out of the list. If you have any process to be done, you can do the process, or if it was just for display, you can display the temporary data, data of the temporary variable at each encounter, and that is done. So that is forward traversal, which is just the same as we do it for singly linked list, the traversal process. Now what makes it different is the backward traversal. Okay, so doubly linked list is also known as double way list because you can have forward traversal as well as backward traversal. Okay, so in the case of backward traversal, first what you have to do, you have to check whether the list is there or not. So if the list is there, the start or head node will be having the value null. Okay, so if it is null, then you have to say that the list is empty, you cannot travel, so you can exit from it. Else, what you have to do, you have to set temp to point to tail, where tail is the node that points to the last, tail is the pointer that points to the last node of the list. Okay, just like we have start pointing to the first node, tail is a pointer that is having a value or having the address of the last node of the list. Okay, if this is not known already, then you have to travel till the end of the list, just like we travel for the forward traversal. Then find out the address of the last node, then mark it as tail. Okay, so you have the address of the last node marked at tail. What you have to do, instead of using the next field value, you are going to travel from tail till start. Okay, tail till start till your temporary variable value becomes null, which means you're going to use the previous pointer. Once you reach the first node, then you set for temp is equal to temp previous, it becomes null. Okay, so if it was for display, you have to display the data. So this is all about backward traversal. What you do is that you start from the last node. So if the last node address is not known, you have to make a forward traversal, go till the end of it and find out what is the address of the last node. Okay, so once you get the address of the last node, you can start a pointer from there and use the previous link fields to advance the pointer. If you are going for display, you can display it, or if it is for whatever be the process of traversal, you can do that. Then you advance the temporary variable, the temporary pointer to the previous node, and this goes on until it becomes null, which means you have reached the first part of the list. Okay, so this is about backward traversal. So this is found only in doubly linked list or circular doubly linked list. It is not available for any other types of linked lists. Now let's see how deletion can happen. So deletion, again, three ways. You can delete the first node, you can delete the last node, and you can delete at any position. So what you can do is that we have mentioned about how to create a node. Okay, how to create a node, how to add it to the list, whether it be at the beginning as the first node or whether it be at the end as the last node or at any position chosen by the user. All you have to do is that think about how deletion can be done, what are the pointers that will be affected while the deletion happens, and prepare an algorithm of your own. If you have any doubt, you can ask me while you are making the algorithm. I'll be ready to help you. So that's all about module 3, doubly linked list. So module 3 finally ends up here. Thank you.